Alright, hello everybody. Welcome to this video on scalars and vectors in one dimension. This video will be a conceptual introduction to what scalars and vectors are, and show you some examples of the scalars and vectors you're going to see in AP Physics 1. To start off with, I'm going to give the definition of scalars and vectors, and then I'm going to give you guys some more general examples to get a better intuitive understanding of what scalars and vectors are. So, like I said, let's start with the definitions. So the first one we'll start with is scalars. Scalars. And scalars can roughly be described as magnitude. And if you don't know what magnitude is, it's roughly equivalent to size. So what's the size of a measurement? How big is a measurement? That might not make a lot of sense initially, but I think through the examples that will help. But before I just dive into the examples, let me give the definition of a vector. So a vector is also magnitude, but it also includes direction. Let's see. Direction, I was a little funky there. So I know, like I said, that might not make a lot of sense, but I think vectors and scalars are best described through examples. So let's start with some examples of scalars. The first example that I came up with is distance. So distance, let's think of a pretty easy intuitive example. Let's say we have a car, and you're told that that car has traveled 25 meters. So a car has traveled 25 meters. And that 25 meters is what the scalar is. The car is just the context of the problem. So let me give a quick visualization of what this looks like. So we have a car. We have a car here. And we know that this car has traveled 25 meters. But we don't know in what direction it's traveled. It could have traveled to the right. It could have traveled to the left, it could have traveled up or down, we don't know, but we just know that it's traveled a total of 25 meters. My second example of a scalar is speed. Highlight this. So keeping with the car example, setting a scene, a car moves at 5 meters per second. And that 5 meters per second is the speed, that's the magnitude. We know how fast it's going, the size of the measurement. Again, I can draw a visualization of this. So let's say we have a car here. We have a car, and we've been told that this car moves at 5 meters per second. But again, we don't know which direction. We don't know if it's going 5 meters per second to the right. We don't know if it's going at 5 meters per second to the left. We don't know if it's going up, if it's going down, whatever. We just know that it's going 5 meters per second. So I hope this gives you a general understanding of, intuitive understanding of what scalars are. Now, so you have a little bit of a comparison, let me go into some examples of vectors. So if distance is a scalar, so it only has the magnitude of how far an object has gone, distance that includes a direction is called displacement. Displacement. So an example of this, again, sticking with the car example, is, let's say a car has traveled 25 meters to the right. And for a visualization of this, let's say, I'm going to draw a car right here. I'm just doing it in gray because this is its initial position. And we can mark this as 0 meters, like this location, 0 meters. And since we know that it's to the right, we're being given some direction, we can draw a line and says, okay, the car has gone 25 meters to the right from its initial position. So the car is now right here. So we not only have the magnitude, or the size of how far it's gone, but we have the direction as well. So we've covered distance versus displacement. Next we can go into speed. So speed gives you the magnitude of how fast a car is going, but it doesn't give you direction. If you include direction, this is called velocity. So as a written example, we can say a car moves at 5 meters per second to the right. So now we have a direction in which the car is moving, to the right. So as a visualization, as I like to do, we can imagine we have a car here, same car, and we've been told that it's going at 5 meters per second, but now we know it's going to the right. So we can draw it kind of like that. So I hope this gives you an idea of the difference between scalars and vectors. But before I finish this video, I want to add one more vector that you're going to commonly see in AP Physics 1, and this is acceleration. So let me scroll down a bit. Acceleration. And more intuitively, acceleration is when an object is speeding up or it's slowing down. And basically acceleration is the change in the velocity. So before I keep going on to that explanation, let's get into an example, because at least I learn best with examples. So a car is speeding up at 2 meters per second squared. That's a little funny of a 2. To the right. Now I know those units. That's a little bit of a... I didn't write this very well. Let me rewrite that. Meters per second squared. That's a little bit more clear. Now I know those units are a little funky. We'll go into them in future videos. But again, we have the rate at which it's speeding up, and we also have a direction, so to the right. So let me give an intuitive example of that. So let's say there's a stop sign. So let me draw a stop sign. So we have a stop sign here. It's going to be a funky little stop sign, not really going to look like one. Stop. And because our car is following the law, the car stops at the stop sign. But then the car sees that there's no traffic coming, so the car speeds up. And the car speeds up at a rate, in the context of this problem, at 2 meters per second squared to the right. So we'll get a bit more into distance versus displacement, speed versus velocity, and acceleration in some of our future videos, but I hope this gives you a general introduction to scalars and vectors and a bit better of an intuitive understanding. In the comments at the end of this video, I'm going to have a link where you can click and download this PDF that I have drawn out if you would like to have a copy of my notes so you can go over on your own time without watching the video. But yeah, that's it for this video, and I hope you enjoyed it. See you in our next video.